Hello. In this video, I'm going to show how a theoretical probability distribution, in this case, the Poisson distribution, um, matches or doesn't quite match a data set. So it's related to the lab project that you're doing in that way, although very different distributions under discussion. Just found this to be a rather interesting example, and I wanted to show it to you. So my data is a data set having to do with hurricanes. So I'm going to load that into a data frame. I'll call it the data frame. I'm going to call that her. So read CSV is the function I'll use here. I have made sure that I have the correct directory where my data file is. And my data file is called hurricanes.csv. It's in comma separated value format. Ta-da! So I have 172 observations. I think it goes back to like 1850s or something. It's how many hurricanes per year along the eastern seaboard, and they call it the Atlantic Basin. So let's have a look and see. I mean, we're going to need to think about this with climate change. There's seems to be more storms, and if we can come up with a theoretical probability distribution for how many storms there ought to be, right? Sometimes you can have more or less, but how do we know whether or not it's unusual? That's what statistics is for. Okay, so I'm going to pick out of that the variable that I need, and I'm going to call it number of hurricanes per year. So that is just the hurricanes variable in the per data frame. Ooh, whoops. Typing is not too good there. Need an underscore now. There we go. Okay, so let's have a look. I'm going to draw a histogram of the. I really type this whole thing out. There it is. Whoops. Ooh, that was scary there. I thought I was going to do a lot of typing. Number of hurricanes per year. What do I want? I'm going to make a relative frequency. That is, I'm going to use relative frequencies rather than the number of years with that number of hurricanes. For my y-axis, I'm going to have probability. And that will make it much easier to compare to the Poisson distribution. I'm very picky about having nice titles. Basin. And pretty colors. Let's go with green. Go. Oh my gosh, that's beautiful. Okay, now to compare with, I'm going to overlay on this graph a plot of the Poisson distribution. And I'm going to do that using the lines function. It's interesting what you can put in there for the x. Instead of just an x variable, I'm going to put a whole sequence of x variables from 0 to the max number of hurricanes. There it is. And now for the y variable, I am going to use the density of the Poisson distribution, right? The density is the probability. That's why I did probability to begin with. The x values, again, same as over there. Let me copy and paste that. Right, those are the x values. The y values are the value of the Poisson distribution probability for each of those. And then for the Poisson, you need to specify a parameter, which is the mean. And of course, it's the mean of the number of hurricanes per year. Voila. And let's do a color. And I don't know about my aesthetics here, but I'll try magenta. Something is going wrong. Looks like I'm missing parentheses somewhere. Let's see. So there's my X. Oh, I see. It's telling me this one starts here and never ends. So it should end here. Oh, no. It should end here. There we go. Oh, look at that. So nice. So there's the Poisson distribution on top of that, and you can see the tail looks okay, but the center is not really where it should be. So what's happening? Not really Poisson. So there are some better methods to check for how good of a fit the Poisson is to this data, but we can discuss that. Oh yeah, I'm gonna have a little typo in my title. -1 point. All right, hope you enjoyed the video. Have a great day. Bye.